Hi friends, welcome to my YouTube channel. In this video, I'll be showing you how to design and simulate a 5G millimeter wave antenna. These are some of the frequency bands which are available for 5G technology. Okay, in this, I'll be concentrating on this LMDS 28 GHz band, which has 27.50 to 28.35 as one band and 29.10 to 29.25 GHz as another band. This is where I'm designing my antenna to work in the 28 GHz frequency band. Now let us start with the simulation part of this 5G millimeter wave 28 GHz microstrip patch antenna. So as a step one, so we'll first create all the variables which are required for simulating this antenna. So to do that, let us go to project, select project variable and add all the variables that are required. So let me just add here the $WP, that is a width of the patch. So let us take this unit type as a length, unit is millimeter, and the value is 4.6059 millimeters. Similarly, let us add the length of the patch, that is $LP, and unit type is length. Okay, units is millimeter and the length is 1.93 mm. So let me just add 1.93 millimeters. Next we will add the length of the feed, so that is $LF. So unit type is length and the value is 2.40734 millimeters. Let us add the width of the feed, that is $WF. Unit type is length and the value is 0.75 millimeters. Okay. So the next thing is we have to add the thickness of the substrate and the ground dimensions. So for that, add $H as a thickness of the substrate, unit type is length, and the value is 1.575 millimeters. Next, we will add the substrate and the ground dimensions, that is $WG. We will enter length as a unit type and we will write here $WP plus $H. That is the width of the ground and the same is used for width of the substrate. Click OK. Next we'll add the length of the substrate or length of the ground plane, that is $LG. Unit type is length. So then we add the value as $LF plus $LP plus $H. Click OK. So now we can see here all the variables are added which are required for creating the geometries. Okay, so click apply and then OK. Now the second step, we will create the geometries. So to create geometries, what we do? First we will create the substrate. To do that, let us go for draw box. Okay, we just draw a rectangular box here. We will label it as substrate. Then the material here, what I have chosen for this substrate is a RT derived material. So I'll just type here RT. You can see here, one second, Rogers RT derived. $5880. One second. Here you can see RT derived 5880 Rogers. Click OK. Okay, and then you select the substrate color as some green color we will choose and then we will apply it. Okay, so substrate dimensions we will specify here. So it starts from minus $WG by 2, comma 0, comma 0. Then the X dimension is $WG. Then Y dimension is $LG. And the thickness is minus $H. So you can see now the substrate material is created. Okay. Next thing is we have to create the feed line. So to do that, go to draw rectangle. You can just draw some rectangle here. You can give name as feed. This is going to be a metallic structure, so I'll just give some copper color, apply. Then I'll just give the dimensions here. It is going to be minus $WF by 2, comma 0, comma 0. Then width is going to be $WF and length is going to be $LF. So you can see now the feed line is created. Next we have to create a patch. So to do that, again I'll take one more rectangle here. So draw rectangle. So this one I'll name it as patch. I'll assign the color as a metallic structure color. Then I'll give the dimensions here. So position will be minus $WP by 2, comma $LF, comma 0. Width is going to be $WP and length is going to be $LP. So click apply. Okay. So you can see now the patch is created. Now let us unite this patch and feed. So to do that, select patch and feed. Just go and unite. So you can see now it is united. Now the next part is we have to assign the material property for this. Let us assign material as a perfect electric. So for that, assign boundary, select perfect electric and click OK. Now let us create the ground part. So to create ground part, again we will select a rectangle and we will draw a rectangle here. So name it as ground. It's a metallic structure. We select metallic structure, then apply. Give the dimensions here. So the dimensions are minus $WG by 2, comma 0, comma 0. Here it is minus $H. Then just give $WG and here $LG. Then click apply. Okay. You can see now the ground is created at the bottom of this substrate. So you can see this is the ground plane, the pink color one highlighted, that is the ground plane which is created at the bottom of the substrate. Next we have to assign material for this. It's a perfect electric. Assign boundary, select perfect electric and click OK. So that's done. Now the last part here is you have to create a excitation. To do that, change the coordinate axis, that is it is perpendicular to y axis, so you have to select ZX plane. So after that, you just draw a rectangle here. So I'll just draw a rectangle here and I will name it as excitation. So let us click OK and give the dimensions for it. The dimensions are minus $WF by 2, comma 0, comma 0. X size is $WF and Z size is minus $H. You can see now the excitation port is created here. You can see this is a port which is created for exciting the antenna. Now we have to assign excitation to this. Right click, go to assign excitation, select lumped port and click next here, select integration line to new line and just draw the integration line from bottom to top of this excitation port. So once it is done, click next and finish. So now we have seen all the parts are created. Now we have to create next the radiation box. To do that, right click, go to create open region, say select radiation here and the frequency I'm selecting 28 gigahertz because we have created this antenna for millimeter wave frequency band of 28 gigahertz. So click OK. Now radiation box is created, and just go to this project manager, click on this plus symbol, and radiation, select 3D, and you just give this theta value as 360 degrees. Click OK. Now let us see, we will check all the materials and boundaries. See here, this is an open surface which is a radiation box. This is a perfect electric, that is my radiating patch. Then we have the ground here, okay, and the excitation port here. Okay, so all parts are created. Next thing is we have to assign analysis, create analysis. So for that, let us click on analysis, add solution setup. Here solution frequency is 28 gigahertz. We'll add maximum number of passes as some 20. Okay, so click OK. Next, click on that analysis plus symbol, right click on the setup one, add frequency sweep. So here we will give the frequency sweep from, say, probably 22 to 26 to 40 gigahertz. Okay, so since my 28 is going to fit in between this, okay, 26 to 30 gigahertz. Let me just give 30 gigahertz. So, and here we will give, instead of linear step, I'll just give linear count. I'll enter here 201 as a points. So let us click OK. So now let us check here. We will validate first and confirm whether any discrepancies are there in this design. So click on this. You can see here everything is perfect. So now it is ready for simulation. Now close this. Just click on simulation. Now we can see the simulation is completed. It shows normal completion of simulation on server. That indicates, okay, the simulation is successfully completed. Now we can take the results out of it. So first let us click on this results. Right click on create model, solution data report, go to rectangular plot, and here first we will create a S parameters plot. So S parameters S11 and dB. This is a selection, and click new report. You can see here a graph is created. Okay, so this graph shows the resonance is happening at 28 gigahertz. A very good resonance we can see at 28 gigahertz, for which we have designed this antenna. At 28 we have minus 20.5265 dB of reflection coefficient. Then let us understand the bandwidth here. Okay, how much bandwidth it has. So right click here, select a marker, add Y marker, and you just select this and move it to 10 dB, minus 10 dB. So just select and right click here and click on edit, go to properties, and then just you set here Y value to minus 10 and click OK. You can see here the two yellow color values are appearing here. That is the bandwidth corresponds to your minus 10 dB line. So you can have here 29.57 minus 26.87. That is a total bandwidth that we are getting. If you find the difference, you can see here, I'll just write 29.57 minus 26.87. It gives you approximately 2.7 gigahertz of bandwidth. That's a huge bandwidth, and we have already saw in one of my previous lectures or videos that is for 2.4 gigahertz the bandwidth was somewhere around 100 megahertz or so, whereas here you can see it is almost like a 2.7 gigahertz. That you can imagine how much is a bandwidth and how much data rate it will support. That is a beauty of moving to millimeter wave frequencies. So it's a huge bandwidth. Now let us go to the next characteristic, that is our say VSWR plot. Select VSWR here and click on new report. You will see here at 28 gigahertz the value should be between 1 and 2. So let us verify whether it is giving that value. So of course it is giving. So the value is 1.2078 at 28 gigahertz, which is well within the range of 1:2. Next we will plot the impedance parameters. I'll select here Z parameter and then the magnitude. So let me just create a new report. And let us see, we got a graph here, and at 28 gigahertz, let me just see what is the impedance. I'm just marking here. So it is showing the value as 41.4186. This is very close to 50 gigahertz. So it's a good impedance matching, we can say. Okay. Next we will plot the radiation properties. The first one I'll plot here, create far field report. I'll just go to 3D polar plot, then gain, and we have to select dB here, then click on new report. You can see here the radiation plot is appeared, and the maximum radiation is in the Z direction with a 6.767 dB of gain. Similarly, we will plot the E-plane and H-plane patterns. So for that, let us go to far field reports, radiation pattern, and then select here gain. Then you can select dB, and families you select here phi as 0, and holding control button you just select 90 degrees also here. Then you just click on new report. You can see here the 2D radiation patterns of this particular microstrip patch antenna. Okay, so you got again maximum radiation in the 0 degrees at 2.4 or 28 gigahertz. Okay, so this confirms us the designed antenna is working at 28 gigahertz. Okay, thanks for watching. Don't forget to subscribe, like and share, and if you have any comments you can please comment in the comment section. Thank you.